Hello everyone, this is Ajit Singh Rana, your host for today's workshop. I will be running a workshop on an exciting topic called how to improve your inner loop development workflow and productivity using Docker. So let us get started. Before we jump into the agenda, a little about myself. I work for Docker as a developer advocate. I'm based out of India. I have been working in Docker for almost like 2 years now. But I have been part of the community for almost 9 years. I was also part of Docker Captains program starting from 2016 till 2022. I have been leading Docker Bangalore community as a community leader. I work very closely with the ARM community and I'm one of the distinguished ARM ambassador. So here are the list of the companies which I have worked till now. Now let us jump into the agenda. This is how agenda look like. So we have split this session into three different labs. For the first 45 minutes, we'll get familiar with the inner loop development workflow. We'll go through high level Docker development workflow. We'll see how to build Docker images using the best practices. Under this lab, you will also get familiar with exciting developer tools like Docker Init and Compose File Watch. You will also see how this tool helps you in accelerating your development workflow. Most of the time, we'll be doing hands-on labs, so you ensure that you have a Docker desktop up and running on your machine. Now, under Lab 2, we will discuss about container-first development workflow. Now, this is an exciting topic. We will show you how developers leverages containers for everything needed to run this application. We'll pick up a sample application with React frontend, Node backend, and a Mongo as a database. And we will see how to integrate this app with the real cloud services. And then in the last section of this workshop, we'll discuss about container supported development workflow. So the container supported development is all about how you use this container to support and enhance development without even touching the main application runtime itself. So under this lab, you will learn how to spin up the mock cloud services locally. So we will be using a local stack. Rather than directly going into the cloud, we will just use local stack to have S3 emulated into your machine. And then this enables you with an efficient and isolated testing without any complex external setup, which we do when we set up AWS cloud. But before we start, let us talk about the housekeeping stuff. Definitely you need to do a lot of hands-on. So ensure that you have Docker desktop installed on your machine. So it's very simple to install. There are a few clicks and you are done. Okay. So let's first install Docker desktop. You can go to docker.com/product docker-desktop and you will land up in this particular page. You have an option to select your own preferred bits based on your make and model of your laptop. Now, once you install Docker Desktop, ensure that you have the latest version of Docker Desktop installed. If you have the recent version of Docker Desktop, we have a new terminal integrated into Docker dashboards, which means that you don't really need to go to the VS Code or any of the other tool. You can just open it directly on Docker dashboard. And say if you have enabled Docker extension, then you should be able to run Docker extension install and the name of the extension. So extension is more like building a third-party integrated tool right on top of your Docker desktop, which means that you can download this extension in the form of the image and you can run it. But before we go ahead and install extension, ensure that you have deselected allow only extension distributed through the Docker marketplace option. The reason being this particular extension isn't coming from the open community, so we haven't published it in the marketplace yet. So once you ensure that you have deselected that option, just say enter and it will just ask you to press Y and that's you select yes. So for the first time, if you are trying to install this extension, try to find out whether this extension is available locally or not, since this is the first time I am trying to pull this extension. So it just went ahead and tried to run it. Now, the moment extension is installed, you will see on the left-hand side that there is a Docker workshop which appears. I can even run Docker extension ls to see that this extension is running or not. Now, the moment you click on Docker workshop, so you have a complete workshop running on as an extension. Under that, you have number of labs. So we have 3 labs as we discussed, right? So most of the content which you are going to talk today are captured in this lab. Now the benefit of this workshop is all about the different like inner loop, and we are also going to talk about container first and container supported. Most of this content are already captured into this workshop, right? And then as a prerequisite, as I said, right, we need to download Docker desktop for your system. So if you haven't followed till now, just go ahead, follow this. And I have also included an instruction how to enable WSL2. Now, if you go back and try to see the container, since this extension is running in the form of the Docker container images, so you can also see in the container. The other than that, if you go to each of these labs, so each of these labs holds a kind of an image for a tech stack, so that you get an idea of what we are trying to achieve. So say in lab 2, we have this particular architecture which we are going to go ahead and set up. So this is a tech stack. Under lab 3, we are talking about container supported architecture. So we'll see like how to emulate the cloud services as in the form of the local stack and running Mongo locally, where you are pushing the images to local stack and text to the MongoDB. So this is how we are going to, complete in this workshop. So, but before that, let's spend some time, like I would say like first 30 minutes in understanding the inner loop development workflow. Okay, so let's talk about the inner loop development workflow. Now, if you look at the Docker ecosystem as a whole, it is a growing and vibrant ecosystem. It provides you with a number of tools and technology which helps developers to create, test, deploy, and deliver software more quickly and easily. Now, to understand how it connects to the so-called software development lifecycle, SDLC, let's talk about the inner loop development workflow. Now, a typical developer downloads the open source software. He or she writes the code, packages them into the executable, and then test it, right? Now, once this code is tested and working, it is built into tar or exe format. This is an iterative process of writing, building, and debugging the code that a single developer performs before even sharing the code either publicly or with the team. And this is typically characterized by the frequent changes to the code as developers learns more about the problem they are trying to solve. Now, if you look at the left-hand side, we have an outer loop development workflow. This loop represent the deployment and delivery of the software, and that's where your CI/CD pipeline comes into the picture. In this loop, the software is tested and deployed on the production environment. Now, if you talk about the inner loop, it is more associated with the development phase of SDLC, whereas the outer loop is more associated with testing, deployment, and release phase. However, these two loops are not mutually exclusive and they can overlap in some cases. So Docker as a company offers a wide range of features and tools to make developer life easier. And talking about the inner loop development workflow and targeting, especially on the inner loop, we bucketize into three major areas. The first one is speed, the second is security, and we have a choice. Now, if you look at speed, right, there are a couple of tools which we have today. We have a Docker init, which is a tool which helps you to build Docker assets, which means that today, if you are manually building Docker file and you are writing Docker compose, which means that you are really missing this new tool which we have introduced in the recent release. So you just say Docker init and it will try to go ahead and identify your application platform. Say if it is a Python, Node, PHP. So we have support for all the leading programming languages, right? So Docker init helps you in building such kind of an assets. We have tools like FileWatch, which means that a feature which allows developers to automatically rebuild their Docker containers whenever you make any changes to your source code on the host. So this is a feature which is enabled for Docker Compose file, and during the workshop, we are going to look into it, how it works. The other tools, other features like VirtuoFS, a feature which allows Docker container to access file which is on the shared file system, right? And you can access it at the faster rate. So with the VirtuoFS, we have seen a lot of Mac users are able to see more and more good performance which they used to have in the earlier days of Docker Desktop, but now it really works great. So we also migrated from VPN kit to gvisor, which means that this is a feature which allows 5x faster container to host networking on Mac OS. Now there are a couple of other features which we are targeting. The first, in terms of security, right, we have tools like Docker Scout, which means that if you really want to go ahead and secure your supply chains, we have a Docker Scout, a tool which helps developers to fix, to find and remediate those security vulnerabilities in their Docker images. We have attestation, a feature that allows developers to verify the authenticity and integrity of the Docker images. So we talked about security. Now let's talk about choice. Under the choice, we have Docker extension, as you saw, right? A library of third-party tools, which helps you to extend the functionality of the Docker. We have Docker sponsored open source project, a collection of open source projects that are sponsored by Docker. We have Rosetta 2, a tool which allows Docker containers, the AMD based images to run on ARM based, laptops like Apple M1 Max. And then just to name one other feature which we have is basically WebAssembly support, Wasm support, a technology that allows Docker container to run these WebAssembly containers along with the Linux containers. Now let's target speed and look at what is an offer. Like, as we are talking more on inner loop development workflow, let's talk about speed here. Now from 30,000 feet, a typical Docker workflow looks something like this. It starts with a Docker build command that accepts the Docker file to package apps as a portal container images. If we talk about images, it is nothing but a standardized package that includes all of the files, binaries, libraries, and configuration to run a container. If you are new to the container, it is something which is in a kind of an isolated process for each of your apps, just like on your mobile phone, you have number of apps which runs without even disturbing each other. So think of it as like each component, like front end, React app, the Python API engine or database, which runs on its own isolated environment, completely isolated from everything else on your machine, right? So once the container image is built and it is ready to be distributed via registry. So image registry is nothing but a centralized location for storing and sharing your container images. It could be public or it could be private. One example is Docker Hub, which is a very popular public registry that anyone can use and is a default registry. While Docker Hub is a popular option, but there are other available options like ECR, ACR, Google Cloud, Google Container Registry. You can even run your private registry on a local system. For example, Harbor, JFrog Artifactory, GitLab, container registries, right? Now, once you have built, you have shared it, and you have pushed it to Docker registry, developers can now pull those Docker images and run it locally on your cloud. So on the right hand side, you can see here that you can run it on, say, on your local machine, on your cloud, on even the Raspberry Pi, like IoT devices. So you can run multiple versions of the same application using Docker run command. And even you can use Docker Compose to pull those images, to build those images and run those service containers and talk to each other. Now, as we go in depth into the inner loop, even though we look at the high level where we are just talking about how you build it, how you share it and run it, but actually as you study the organization, as Docker is more focusing on the inner loop, in a typical org, you see that there are a number of developers performing their own, preferring their own operating system. They might use Windows, Linux, or Mac. Using their preferred IDs, they commit the code through GitHub Action, build images, and push to the registry. So each developer has their own choice of tools they use. Let's assume that you are building a Node.js sample application. So typical workflow would look like you clone the repo, you do Docker init to set up or a new existing npm packages, and you do npm install to install those packages or any packages that it depends on, and then you add some kind of a code. So this is one example where to test this application is working properly, you will first do the post some JSON to the API and then make a GET request to see like data has been saved or not. So usually you test it through some kind of a curl command as shown. Now, if you take this application, if I have to create a Docker file, so usually Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. So when we tell Docker to build an image by executing Docker build command, Docker will read this instruction and execute them one by one. It will also create a Docker image as a result. So usually you start with creating an empty file called Docker file, and then the first thing you do is define from what image we want to build it from. So you can see in the example here we have a node, so I'm just specifying node. Next, we create a directory which will hold this application code inside the image. So this will be kind of a working directory for your application, and that's where your work come into the picture. So this image comes from Node.js and npm already installed. So the next thing we need to do is install your app dependency using an npm install. You copy few of the source code, right? Which includes like the package.json, you expose it and you run it as node server.js, right? So this is how you write a typical Docker file. Now, once you write this Docker file, the next command would be how to build it, and what we use is Docker build command. And then you can always use Docker run command to run it on a specific port. Okay. So today building Docker image is easy. Docker file has been there for a long time. The instructions are all captured under our docs pages, but there are certain do's and don'ts which you need to really take care of. There are around, I would say, like right now we are going to talk about 10 to 12 different best practices of how you build those Docker images in order to keep it slimmer in version so that they are optimized. And since these images will be used by the Kubernetes when they are deployed over the cloud or any of the orchestration engine, you need to ensure that these images are really optimized for such kind of workload. Now let's talk about each one of them one by one. The first one is, it is always recommended that you use the explicit base image. So in this example, you can see on the left hand side, I have a Docker file where the base image says latest. Now when you say latest, it is unpredictable because these bits are coming from the community. And on the right hand side, we have a very explicit version, say 16.17, which means that you already have tested these kind of a Docker images with this specific version, which ensure that the build is predictable and there are no any other future changes which goes into it, right? So it is always recommended that you use explicit base image, which will help you in uncrashing your application. The second one is prefer linear Docker images. The smaller the Docker images, the more powerful way or more optimized it is, as well as it is very easy to move from one machine to another. Now imagine that you have built a Docker image and that is used by hundred of nodes of the Kubernetes cluster, which means that these images are moving from one node to another. They are different replicas of the same image which are being replicated across the number of clusters, right? So in this example, you can see here, I have been, on the left hand side, you see the node latest, which might be kind of a, MB 600 to 700 MB size, whereas the node LTS slimmer version, which means that you can only pick up those slimmer version which contain the software which you require for your application. In one way, you can see here that if I pick up, say, 16.17, it is more like a 333 MB, whereas the slimmer version is just like a 62 MB. Now, ensure that when you pick up a slimmer version, you should have a prerequisite or at least a minimal packages which you require for your application. The third one is multi-stage build. As you know that when you try to build an image, most of the time it contains the build tools which you might not require for your end build, right? So in this example, whenever you write a Docker file, it goes through number of stages, picking up the base image, trying to do npm install, where it goes ahead and try to install all the intermediate packages, and the final build has something which is like a blotted, right? Now in this example, you see there are multiple from statement. This is how you recognize multi-stage build. So in the first stage itself, you have a build tool, and the second stage will just use the final build, which means that the second version is going to be a very minimal size. So if your Docker image is like close to around 1 gig, you can bring it down to say 200 to 300 MB, even less, with multi-stage build, which helps you to optimize this build. And the final build will just hold what the application requires rather than holding those intermediate builds. Now, in the fourth, best practice is like whenever you build an image, it is your responsibility that the images should not hold the vulnerabilities, and that's where your Docker Scout come into the picture. It's interesting that most of the security tools today which exist will only take care when they are in the outer loop. Once you push it to the registry or put it in the CI/CD pipeline. But the beauty of Docker Scout is that you can use Docker Scout in the inner loop development workflow. The moment you use Docker build command, Docker Scout is already there. So today, Docker Scout is available with Docker Desktop, as well as if you are on Linux or Windows machine, even you can install those CLI and you can use it. Docker Scout helps you in finding the vulnerabilities, in fixing the vulnerabilities and remediation. And it also comes integrated with all the CI platforms like GitHub Action, GitLab, Azure DevOps Pipeline. It also integrated with the registry like ECR and JFrog Artifactory. The fifth best practice is that whenever you write a Docker file, ensure that, and you are hosting some kind of a web application, it is always recommended that you use some kind of a health check, which means that say if your image is used in the Kubernetes cluster, at a time you will be, one way how you troubleshoot that your application is working fine or not is through the logs, right? And this health check is going to throw the logs, and it becomes easy for you to go ahead and especially fix the issue. So under Docker file, there is an attribute called as the health check. You can add that kind of an instruction. So in this example, you can see like there is a Node.js based application on the front end which runs on 3000 port, and you can always see like there is during a certain time period there is a kind of a health check, the heartbeat in the form of the heartbeat, right? You can see that why my application is not working fine, right? So those kind of health check you can still do with the Docker file. And this is one of the example. Once you set it up, you will see that health starting. This is a status which it shows when you run docker ps command. Just like a .git ignore, we have a .docker ignore, which means that during a Docker build process, say one of the directories are node modules, you might not require node modules once it is built in the form of say multi-stage build. You can still use the .docker ignore to ignore those build tools which you might not require as final build. It's obvious that, and it is always recommended that whenever you try to build any of the Docker image and run it in the form of the container, it should run as a non-root user. This is very important for most of the time, not just like a high performance computing, but most of the time that when you run as a root, it means that you are exposing or you might be mounting some kind of host files which gives access to your host, and anyone can go ahead and throw out some kind of a malicious code into it, right? So it is always recommended that you run it as non-root user to secure your host system. Most of the time, I have seen that when we try to build these images, we always try to build it on the platform which we have. Say, if I built something around 5 years ago on Intel chip, that might not work on my newer Apple MacBook. The reason being those images has been built for only the AMD based or say AMD 64 based platform. So it is always recommended that whenever you build an image, you build it for multiple architecture, so that even if tomorrow, if I want to run it on IoT devices, I should be able to run it. And today we have a capability thanks to Docker buildx command where you can specify the different platform and make it work. Even though it is not a kind of a best practices, but what I have seen based on the interaction which we have with the number of developers is that sometimes your application is slow. So it is always recommended that you need to have some kind of an open telemetry. One example is a Signos, which is an open source open telemetry platform, which helps you in finding, okay, what the metrics, the logs and traces, you can find it out, so that just like most of the time your machine is slow, in the same way container can be slow. and the culprit could be your application. There might be some kind of JVM specific error or some kind of application related issues, right? So it is always recommended that you need to open telemetry to ensure that or your application is up and running and to measure the app performance. And finally, not only on in Docker file, we have health check in Docker Compose also, and you can see in this example that I can set up the similar kind of the health check in the Docker Compose too. Now this looks really interesting. There are best practices, but for a new beginner, it might be a tedious work. And that's where your Docker init come into the picture. So Docker init helps you to build Docker assets with the best practices. It was introduced for the first time in Docker Desktop 4.18. It helps you to generate Docker assets. Today we have support for all the programming language, most of them which are like a leading programming language like Go, Node.js, Java, ASP.NET, Python, PHP, right? And the beauty of Docker init is that it helps you to identify your application platform, and based on that, it will create an assets for you. So in few minutes, we'll see a demo kind of it, but let's talk about how Docker init can benefit you. First thing is it makes an asset creation easy for any beginner, right? If you have to start with a Docker file, the first thing you need to do is go to the docs.docker.com, try to go through the Docker file, and it's a massive file, how the instructions are written, and this command will just ask you like 4 to 5 questions, and then your Docker file is ready. It saves a lot of your time and effort, definitely, because I don't really have to worry about those best practices. If I have a front end and the back end, I can run Docker init specific to each one of them and then try to build a Docker file or Docker Compose file. So it gives you both. And that ensure that, in whichever platform you are, say Windows, Linux, or, Mac, if you are using Docker Desktop, you have a Docker init into it. So Docker init is feature which is only available in Docker Desktop. If you are using Docker Engine, you might not be able to see this command. So with this, we'll jump into the demo. We'll quickly see like how we'll pick up a kind of a Node.js based application and try to use Docker init to create Docker assets. So let's go ahead. Okay, so let us jump into Docker init demo. So if you go to the workshop, you can see here that we have a specific page for Docker init, which talks about what are the benefits of Docker init, when it was introduced. And also you will see that there are few of the instructions here. So let's go ahead and clone this repo. So ensure that you have a Git installed on your local machine. So as this is the first time I am cloning this repo, so it will take its own sweet time here. So once it is cloned, change directory to Docker init demos, and ensure that you try to go ahead and install npm install. You will see some of the error. The reason being we are in the wrong directory. So let's change directory to node. So this is an public repository. So you just have to clone it and start installing it. So without Docker, a typical workflow looks something like this. You just say Docker install and node app.js, and I can go to the browser and see hello from Docker. This is a very simple HTTP based application. Now let's cancel it. As you can see here that the simple way how to go ahead and convert this Node.js based application into a containerized environment, it is more like just using Docker init. Now if you use Docker init, automatically it detected that this is a Node.js code. So it detected an application platform for you. It asks you about what version of Node do you want to use. It picked up by default the version which you are using on the host machine. Select npm as a package manager. Then you can specify what command you want to use to run the application, and then finally specify the port as 8080. Now once you do this, it creates all those assets for you. You have a Docker file, compose.yaml, .docker ignore, and the readme file. Now before we run Docker Compose to bring up this particular service container, let's look at the Docker file itself. Now if you ask me to create this Docker file, I might end up in 5 to 6 lines, but look at the massive line of code which it has the especially the instruction which it has given. So it followed all the best practices of specifying few of the arguments, sending it, storing it in the environmental variable, their working directory. As one of the best practices says that you need to run it as non-root user, so it created user, it copy all those prerequisite files and then run it as node.js. And if you look at compose file here, so in the compose file, you can have a compose file for one single service. So it just went ahead and created it, and you can see here the environment variable is a node env production, which means that it is built for the production environment. You can also see a specification or a template for database. So let's go ahead and try to copy this command, docker compose up -d build. So it will try to build it and run this particular service container in a background. So you can see here that my node.js application is up and running. I can go to the container and see that this particular application should run as port 8080. You open in the browser and then you can see this application. So it just took me around, like, I didn't write any docker file or docker compose file, just took few of the commands, few of the questions answered, and that's how you containerize a node.js based application. Even in the docker dashboard, I can look at the stats and examine it. So it was really quick to build a node.js based application. Okay, so next we have compose file watch. It's a command which has been introduced in Docker Compose 2.22.0, which automates your update process for running a compose services as developer edit and save their code. So let's jump into and try to understand few of the concepts. So what is Docker Compose Watch and what problem does it solve? So Docker Compose Watch, which we call as file watch, it monitors the file in your project directory for changes. So imagine that you have 100 of those services which you have specified in your compose file, and these services are dependent on each other. Imagine that you have a front end, you have back end, you have a database. Your as a usual process, right? The first thing is you need to have a database up and running, then your back end, and then front end, right? And how this front end is going to talk to the back end. Now there is a lot of dependencies in between these services, and if you make one single change in your source code, a traditional way is that you always have to go ahead and restart those services. So Docker Compose File Watch will help you save your time, because whenever it sees that there is some kind of a changes which has happened in a source code, it automatically goes ahead and try to rebuild the services based on the attribute which you have specified in a compose file. So Docker Compose file works by monitoring your files in your project directory for changes, and when the file is changed, Compose will either rebuild, sync or restart based on the attribute which you have specified in your compose file. So in this example, you can see right now we have a develop attribute. So xdevelop is something which was in the beta, but feel free to go ahead and use the develop. And now for each of these watch attribute, we have a certain action which we specify. Let's look at those actions. So there are 3 actions, and which you can specify under the watch attribute. The first one is sync, rebuild, and then sync and restart. Now the sync action specify a path to watch the changes in the host file system, just like the sync, how you do it from your host to the container, right? The similar kind of a way, like, the sync action works. And then you have to also have a corresponding target path inside your container to synchronize the changes to. In terms of rebuild action, you specify a path to watch for change in the file system, and it triggers the rebuild it. So think of it as like if there is any changes in the package.json, and if I specify that the action should be more like rebuilding it, so it just go ahead and rebuild whenever there is any change detected. And sync plus restart have both the actions incorporated into it. So what problem does Docker Compose File Watch solve? The problem it solves is you don't really have to manually restart your services every time you make changes to your code, because this could be a time consuming or disruptive, right? Especially when you are making a lot of changes. With file watch, you can make those changes to your code and see the result immediately. So it involves a lot of benefit. The first one is the rapid feedback loop. So developers can receive those immediate feedback on code changes. As they save their file, the running compose services automatically updates, eliminating the need of manual rebuild or restart. The second one is the reduced build time. So by synchronizing only the change file, you optimize the build process, you reduce the time required for the image build, and it automatically eliminates the need to rebuild the entire image for every code modification. And the third one is a seamless container update, which means that now FileWatch ensure that developers always work with the latest code, because they don't really have to go ahead and restart manually. As the changes are detected, the relevant files are synced and containers are recreated whenever it is necessary. Now let's go ahead and try to see the demo. So let's start with Docker Compose FileWatch demo. If you go to Docker Workshop extension, under the lab 1, we have an overview of Compose FileWatch. So whatever we discussed till now, especially on the Compose FileWatch, what are the different types of the actions it has, everything has been captured here. And you can see here, this time I have used watch attribute with a certain path, target, actions. So you can find all the details under this workshop. In this workshop, I have also workshop page. I have also discussed about the brief explanation of all these actions, especially under the watch attribute. And if you haven't specified these actions under Docker Compose, and if still you are using Docker Compose watch, it is going to give you the information saying like watch has not been enabled for this Docker Compose file. So this is a brief explanation about how you go ahead and rebuild, sync, and sync plus restart. So in this demo, we are going to target rebuild, and I will show you a typical Node.js based application and how to use it with Compose FileWatch. So for this, follow the instruction. Let us go ahead and clone this repo. So this is a kind of a to-do list application which uses front end the React, the back end as a Node.js, and Mongo as a database. Now, once you do this, you need to switch to Compose FileWatch branch. So git checkout Compose watch. So most of the code are placed under this particular branch. Let's go through this Compose file. We have a front end and we have a develop attributes here. The action is called as rebuild. So whenever there is any change which happens in package.json, it is going to rebuild it. So we have a backend which is a Node.js. So you can see it running on port 3000. So that is what we have specified here. And then we have a database called Mongo, which runs on a specific standard port 27017. And then we have a Mongo Express, which is like a UI for Mongo, just to showcase in terms of demo. Now to bring up a kind of these services, we have Docker Compose watch. This was a new command which was introduced, and you will see that there is a watch which is already enabled. I can go to the containers and I can see that this particular Compose file is up. There are like 4 different services which are up running on a specific port seamlessly. Now I can click on localhost 3000, which is my front end, and I can start adding the tasks, say buy grocery, and I can add it. Let's add the second one, pick up my kid and get it added, right? So you can see a simple to-do list application which uses React frontend, backend as Node.js, and Mongo as database. So ensure that all of these services are up. So now let's go ahead and try to make certain changes in a package.json file and try to see how it rebuilt it. So I open a new terminal here, and I just ensure that you go to the right directory here. So let us go ahead and pick up front end and try to make certain changes. So you can also go to the workshop and look at this particular step. So if I go to lab 1, Compose watch, And this is the section which talks about the new changes which we are going to make. So under the front end package.json, for the demo purpose, let's go ahead and change this version from 2.1.2 to 2.1.3. So I am in a new terminal here. I will open up package.json. And if you remember, I have a rebuilt action set up for this particular file. So let's go ahead and change this to 2.1.3. And you can see here the watch is already enabled. Now the moment I save this file by making the changes to 2.1.3, you open the first terminal and you can see that service has already started rebuilding because there has been a change which has happened on package.json file, and the specific action which I've specified is rebuild it. And you can see here it was so quick that it didn't, my application is still up and running. I can go ahead and add any new task like watch Netflix and still it is working fine. So which means that I don't really have to go back, restart those services. It is taken care by compose file watch, right? And just to ensure that all the services should be up and running. So one of the example is Mongo SH. It looked like this particular container doesn't have that. We are going to use it in future. But let's look at the Mongo Express here, which runs in port 8081. Now go to the browser and say localhost 8081. It will specify the username and password. So by default, there is a specific username and password which we have specified in the compose file. But instead of going to the compose file, let us try this out by specifying admin and pass as a password. Once you log in, you can see that there is a to-do app collections. Under the collection, you can see all those items. There are text. So this verifies that whatever we are adding to the to-do list application is basically going to the database. Okay, so we completed the lab 1 where we talked about Docker init, compose file watch, we saw the demo. Now we move to the lab 2 section where we are going to talk about container first development. Now the container first development, it takes the concept of containerization a step further, which involves using container for every aspect of your software development. So let us get started. Now, as I said, right, it involves using container for every aspect of software development, which means it also includes the application runtime, which means that now developers can ditch the traditional local installation and leverage containers for everything needed to run the application, right? So what does it mean? So in typical container first development, so developers work within a containerized environment. So in this example, you can see here, I have a local system which runs front end as well as the back end, and that too they run inside a container. And how they are going to talk to each other is through the Docker compose file. But you will see there are other components like say S3. So if I am building a to-do list application and if I want to leverage S3, I can even specify that in my compose file. So you can see here that in this to-do list application, we are not just typically passing those text or to-do task, but we are also adding the images, and these images is being stored on your remote AWS cloud, real cloud S3 bucket, right? So in a typical container first, what we do, we clone the project repo, we run a command to start our development environment, and this command will pull all the pre-built container images, which even contains the application runtime or any kind of a dependency, and that's it. The development environment is up. It runs entirely within a containers. There is no need to install the application runtime or specific libraries. Now there is a benefit of container first development workflow. The first one is the portability. Definitely you just need to build those compose file, store it in the GitHub. Anyone can go ahead and clone it, and developers only need to run a container engine or IDE to work on the project, right? And this ensures the identical development environment regardless of the underlying operating system or pre-installed software. The second benefit is that there is a faster setup, because now there is no time wasted installing the application runtime or fiddling with a local configuration, right? Developer can start coding as soon as the containerized environment is up and running. You also get a kind of benefit of containers because containers are like an isolated process. So there is an improved isolation. Each project runs within its own isolated container, preventing the conflict between the project or dependencies from interfering with the other application on the developer's machine. And this also ensure that you have a smooth collaboration, as you know that these codes are placed on GitHub, anyone can clone it, try to run it on local machine. So you get maximum portability, fast and streamlined development setup, and strong isolation, right? Now to see it in action, let's go ahead, try to clone a to-do list application and try to see how we can push this text to Mongo Atlas, as well as how you push these images to AWS S3 bucket. So let's get started. Okay, in order to see container first development workflow in action, let us go ahead and try to see the demo. We'll set up a to-do list application with all those different components. So if you go to the workshop extension under the lab 2, you can see especially the tech stack here. We have a front end which is based on React Material UI. We have a backend for Node.js. We have Mongo, and as well as we need to set up AWS S3, right? And if you look at the S3 setup, the first thing is you need to so one of the beauty of container first deployment or development process is that there are a lot of manual steps which you need to go through. The first one is AWS. So if you look at, you need to log into the AWS, create a user, add a user called developer. Like just for this particular demonstration, you create a group, you create a user group for it, right? And you add a developer to the admin group. So there are like 6 to 7 different steps. You review it, you enable the access key and the security key, right? And then you create an S3 bucket. So there are a lot of steps which you do, and this is just like a very basic one. And once you have done that, we will follow this step. So let's go ahead and try to see how to build one. So what I have done, I have already cloned this repo. So getting started to do app is a repo, and ensure that you are under the first AWS Mongo branch. So you can see here, so the container first AWS Mongo is the name of the branch. You switch or check out this particular branch. Now there are a couple of environmental variables which you need to specify. Ensure that you have .env file. So I have created an env file which requires a MongoDB URI. So I'm not using Atlas at this point of time. We will be deploying it locally for this particular demo. You have JWT secrets which you can create a token. You have AWS access key. This is a real access key which you require. The secret key, AWS reason, and the S3 bucket name. Okay. So I have specified all of them under the file. You can see here most of these entries are under the .env file. Now, before we go ahead and run Docker Compose watch, let us see if we can run. Let me show if we can. We need to do some kind of an AWS. Okay, let me go ahead and open AWS access. So what I have done, I have already set up S3 bucket. I will just log into the console. And you can see here, I have already created an S3 bucket called as VAT bucket. And if I click on it, right now there is no items into it or no object into it, right? So let's see how it works. So right now, what we are going to do, we are going to bring up this Docker Compose watch, right? So let me go ahead and try to run a command called as Docker Compose watch. Now, once I do Docker Compose watch, meanwhile, let me stop this and let me show you how the compose look like. So there are a couple of services here. The first one is your backend, where I've specified, okay, Docker file, okay, this is the context, my Docker file is under /server, it should run on 5000. And as I said, right, instead of passing the environmental variable, I have put it in .env file, right? Usually we don't go ahead and upload those file into the GitHub, but create it locally. And then I have a watch command. So if there is any changes which happens to the package.json, I don't really have to rebuild all those services. Under the client, you can see here that most of the entries are same. Again, we have a watch command, we have a MongoDB, right? This time I'm not taking Mongo Express because MongoDB itself, we can run those commands and try to see all those collections. So this is a very simple uh, way of how you basically build a Docker Compose file. So right now, if you see, most of these containers are up and running. So I have a client, Mongo server, everything up and running. I can say click on 3000 port. So let me show you. So let me open localhost 3000, and you can see here the to-do list application is up and running. Now let's create a kind of a demo user to, I'm just, let's register a user first. So I have a demo user 2 and demo user 2. So this application also provide you to register it. Once I register this, I just need to log in at demo user 2, demo user 2. And once I log in, so it will show me, okay, you can refresh it, you can filter by tag and to do. So I will just go ahead and click on this title. So I will say buy grocery, right? And this is going to be a demo task, and tag I am going to pick up a task. Now I am going to go ahead and upload some kind of an image. Say if I pick up this particular image which I have and try to upload it and try to save this. Now once I save it, the text is going to go to the Mongo as well as the image is going to the AWS, and I can quickly verify here by refreshing it, clicking on it, and I can see this image is right here. So which means that the moment I added the images, it went to the S3 bucket. So you can see here I didn't change any of the code, right? I tested this particular Docker Compose file, just passing an environmental variable. Now you might ask, okay, can you show me how it went into the MongoDB? So I can go to the Mongo here and I can type Mongo sh. I can log in into it, right? So Mongo has DBS. So right now, if you see, there is a database which has already been created. I can use this DBS, and then I can also then later point of time I can even say show collections. So it says to dos. The way how it works is I can say to dos and show documents and click on it, and it will show me. Okay, let me see if I have a write command. So I need to pass the write, and here I can say count documents, and you can show like there is 2 items which is there, which means that my MongoDB is able to collect all those text as well as my S3 is now holding all those images. So this is one of the example where we have a front end, you have a back end, containerize and then connected to the S3, connected to the MongoDB which is running locally, and that's the beauty of container first. You have everything containerized, right? Now in the next lab, we are going to see how we can use a local stack. So rather than disturbing your front end and back end, we are going to use a local stack to emulate the S3. Rather than every time I don't really have to go to the AWS and ask for those permissions or configure IAM role, and then instead of using Mongo Atlas, I can still use MongoDB, which you have already seen locally. Okay, so now we move to the last lab, which is rightly called as container supported development workflow, and I'm super excited to show you kind of a demo. So let us get started. Now, when you talk about container supported development workflows, it is different from the container first, because in container first, we were trying to containerize the overall application along with the runtime. But in container supported, what we do, it is the way how we use container to support and enhance development without even touching the main application runtime. So imagine that you have a front end, you have a back end running on your bare metal machine, or say on a VM, and that is uncontainerized, right? we are not containerizing it, but it is just like the manual way how you run the front end and the back end, right? So imagine that now you want to add another service. So without even disturbing that particular service, how you are going to leverage the containers, how these containers are going to talk to each other. So what does it mean? It means that developer will now run their application using a runtime installed natively in their machine, which could be say JVM, Node Engine, or Python interpreter, but the external dependency will run inside a container. Now, this holds a lot of benefit. The first one is without even disturbing your entire setup, you just wanted to plug in the containers, right? So it gives you all the flexibility. The other way around is you can plug and play with the container. Say, imagine this is a particular tech stack where you have a React front end, you have a Node.js backend, and now instead of using an AWS cloud service, I might be using local stack, which might be running inside a container. So I have a front end and back end, which are like normally running on your system, and they are not containerized, whereas I have a local stack, which is containerized application, and it is basically simulating my AWS S3, which means that I don't really have to go to the cloud, make those configuration, and even try to, pay through the credit card, right? And the same thing holds for the MongoDB, which I can run it locally. Now for this demonstration, I am going to show you and pick up the existing application, which I am running inside the container. But imagine that you have a front end, you have a back end running on your bare metal machine or VM, and now you have a local stack which runs inside a container. So with this, let me take you directly to one of the demo, which I am going to show you here. So I can go ahead and remove one of the demo environment which I was already running in my setup. So let us go ahead and open up the workshop. So if you go to lab 3 here, I have all this information. The tech stack looks something like this. You have a front end, you have a same back end, the database, Mongo, and now the object storage will be local host local stack rather than being the AWS S3, right? Now if you go to the last section, which is bringing up the services, so all you need to have a Docker desktop installed, which we already installed. We have a JWT secrets, which you can click using this particular link. Now what we are going to do, we are going to clone this repo, and this time it is the same repo which we have been using it all throughout the workshop, but we are going to switch to a kind of a container supported branch. So if I go and say git status, it will show me that it is container supported here, which looks good. And now once you are into the container status, let us go ahead and look at the compose file here. So when you look at the compose file, it start with your front end, back end, right? So let's start with the back end here. Under the back end, we don't have an environmental variable passed. The reason being we can pass it .env, but if you really want to do it, this is not the best practice, but if you really want to pass the environmental variable, you can have a dummy piece here. So you have a MongoDB URI, JWT secrets, we have an endpoint access key. So it is always recommended that you create .env file for all of this. But yes, and if you look at the bucket name, which is like a dummy bucket name, which is sample bucket, we need to create it manually once we run a Docker compose file here. Now the same thing applies for the client. In the client, we are just specifying the app URI, where is our front end and especially what is the back end. So we have a server colon 5000 because this is where our server is running, and you can look at the port here. Now this particular service depends on local stack. So the specification of local stack is right here. Now this is again, if you go to the local stack website, you will see that, and let me show you. So if you go to the local stack website, it gives you about the CLI, Docker, and Docker Compose. And I've just went ahead and picked up all these entries. So ensure that you have all these entries, which are, especially the image, the port, the environmental variable. And under the environmental variable, I have also specified the services as S3. Ensure that you have this as a small cap S3. So most of the time we just make it as capital and then it doesn't work. We have a volume, we have a network. So this is a kind of an IPAM which you need to go ahead and specify here. So you have to specify this particular subnet here to make it work, because local stack look like it needs its own network to connect. So this is how the specification look like. Now imagine that you have a front end, you have a back end, and all these environmental variables are sitting on your local machine, and you have just a Mongo or local stack running inside a container. So what I need to do here is bring up this particular compose file. So I can go ahead and start this compose file, and this will bring up all of my cluster talking to each other. So I can go to the containers here. I can see this getting start to do app up and running. And if I click on local stack, it says it's ready. I can go back to the workshop, go to the lab 3 services. Now one of the manual stuff which you need to do here is, right now we don't have we are not using AWS S3 bucket, right? So the thing what we need to do here is we need to create this S3 bucket manually by running this command. Even though it says like local stack container, but I want you to run it on the local machine. So this is how you create it. So before we run this, let's go to the local stack. And once you run this sample bucket, you can see that sample bucket is already here created. Now, since you have an application up and running, I can quickly go to the React app, log out, right? And then I can follow the same procedure. Just like an AWS S3, I can go ahead and register here. So I can say demo user 10, demo user 10. So it is just like, I'm picking up some kind of random names. And now once I log in, I can now add a to-do, right? So if I want to watch, say, Prime, I can write any of this entry and I can save it. And now this particular application, if you connect image, it will go to the local stack. But now I have this to-do list application. I can quickly go back to my Mongo and click on it, go to the exec, and I should be able to see a kind of show DBS. So my to-do is here. I can use this show collections, and it will show me that there is a, I still need to go ahead and use this collection. So if I say to-do -app, so it is going to get into this. Now this time I have a collection called as to-dos. So I can say db to-dos count and documents. The easiest way is using a Mongo Express, but you can see that there are 2 items which is there, which I have already added. The one in the container first, because it is mounting to the same directory. In the same way, if you go ahead and upload those image, that is going to go ahead and sit inside a local stack. With this, we finished this particular workshop. We talked about, as I go to the workshop here, you can see here we covered all of those labs, lab 1, lab 2, lab 3. We talked about the inner loop. We went into Docker init, compose file watch. We talked about container first development and container supported. So I would request you to go through this, all the labs, and in case you find any of the issue, just reach out to me. Thank you so much for being with me throughout this workshop. Thank you.